Hello and good afternoon, CSI158 Section 847 students for the Spring 2014 semester at Anne Arundel Community College. Today's PacketTracer tutorial is going to be on PacketTracer Activity 3.2.4.7, where we're going to be troubleshooting a Vlan implementation scenario. So let's go ahead and take a look over here to the right, where we can see we've got 6 different PCs, and we've got some different subnet addresses, and then we also have some different VLANs, and obviously each PC is plugged into a different switch port. So let's go ahead and jump in. So in this activity, we're going to troubleshoot connectivity problems between PCs on the same VLAN. The activity is complete when PCs on the same VLAN can ping each other. Any solution you implement must conform to the addressing table, so we need to make sure that we follow what's up in the addressing table here. So let's test connectivity right now. Let's go ahead and pull up PC1, and we're going to see if PC1, we'll bring PC1 down here into the center. So can PC1 ping PC4? Let's give it a try. So we'll say ping, and PC4's IP is 172.17.20.10, sorry about that, .10.24. And chances are it's probably not going to be able to. That's why they're asking us to give it a try. So can Pc2 ping Pc5? Let's pull Pc2 up here and see what's going on. All right, so we'll pull Pc2 up, and we're going to say ping, and Pc5 is 172.17.20.25. Chances are that's going to be broke as well, and then we'll go ahead and let it air out here a couple times, request timeout. All right, now we'll jump onto PC3 to confirm that PC3 is also unable to ping PC6. So 172.17.30.26. And this should fail as well. So it says investigate connectivity problems by gathering data. So let's first do what you would do in a normal troubleshooting scenario. Let's go ahead and validate the IP address and the subnet mask for PC1. So we'll close, well actually we can do it from right here. So let's go ahead and, I like the command line. So we're going to say ipconfig dash, or forward slash, I'm sorry, slash all, and we're going to roll back up here, and that gives us a whole bunch of information. So here is our IP address. So let's confirm. Is PC1 172.17.10.21? It is. And all of our subnets are conveniently /24s, so let's confirm that. All right, we've got no gateway, no DNS setup, no DHCP. So we've confirmed our subnet mask and our address for PC1 is correct. Let's check PC2. So we'll say ipconfig /all. And PC2, we've got the net mask is correct. The subnet mask is correct, /24, 255, 255, 255.0. And now we take a look at the IP. And so PC2 is supposed to be 172.17.20.22, and it is. Let's pull PC3 up, go ipconfig -all. And the IP address is 172.17.30.23. That is correct. The subnet mask is correct. Now we'll sneak over here to PC4, and let's go ahead and stay on the command line here. So PC4 is 172.17.10.24. That's correct. /24 is correct. And let's take a look at PC5. And if you wanted to look, if you didn't want to use the command line, you could simply click right here. I'm sorry, right on the IP configuration area. So for this one, we'll take a look. So it's 172.17.20.25 for PC5. That's good, and it is a /24. We'll bring that up for the next time we come around to it. And let me go ahead and one last time ipconfig /all. So 172.17.50.26, and the subnet mask is correct. However, when we take a look at that IP address, that is not the IP address that we are using. So let's go ahead, confirm that it does say 50, and we need to fix that because it should be 30. So I'll close this down, and now let's see, does that resolve the issue? Can I ping back over to PC3 172.17.30.23? And let's see if that resolved the issue, or if there may still be a few things that we need to troubleshoot. All right, so it looks like it's going to time out on us. So the IP address on PC6 was incorrect, and we've made that change. So it says verify the configuration on the switches. So we need to make sure that, and I'm going to bring this back down so we can see that addressing table up there, because we're going to be looking at some port assignments here. So PC6 still broke. So first let's start with switch 2. Over on the left-hand side here, and let's go ahead and extend this out, get some more real estate. And I'm actually going to slide that up just a skosh to give us some more room, and there we go. All right, so we're on switch 2 now, and so what is it asking us to take a look at? Well, it wants us to look to see, do we have the ports assigned to the correct VLANs? So I'm going to go from user exec into privilege exec, and then I'm going to go ahead and say show run. And so what are we looking for? We're looking at FA06, 11, and 18. So let's take a look at FA06. And FA06 goes to PC3, so it should be in VLAN 30. Switch port mode access, switch port access, VLAN 30. So FA06 on switch 2 is correct. So now let's take a look at FA011. Aha, so now this may be an issue. So FA011, PC1 connects to FA011. And so it is also in VLAN 30. However, PC1 should be in VLAN 10 according to our addressing table right here. Right? So let's go ahead and do Q to quit out of that, and I'm going to go into global config mode, and let's address this right now, interface FA011. And we want to say switch port access VLAN 10. So I'll type in, and I'm going to type right mem to save my config, and then I'm going to say show run. Whoops, went a little too far, so there we go. So now this port is an access port, and it's in VLAN 10, FA011 that is. We've got some spanning tree activity here, and that's going to go ahead and converge while we continue to look down at port 18. FA018 is PC2, and it's supposed to be in VLAN 20, so that is correct. And let's go down a little further, and you can see here we've got gig 01 is our switch port with a native VLAN of 99. However, it's set to switch port mode access. So if I were to say show interface trunk, we don't see anything, because even though this command is on the port, that command is not the command to set the port to be a trunk port. Okay, so we need to make this a trunk port, and this command right here, this switch port mode access, right, it's going to make it believe that it's an access port. So if I were to say show interface gigabit 01, oops, sorry, gigabit 01 switch port, let's take a look and see how we're set up. So the operational mode is static access, right? The administrative mode, it was set to an access port, so it believes that right now it is an access port. So let's go ahead and change that. So we're going to go into global config mode. I'm going to go into interface gigabit Ethernet 01, and I'm going to say switch port, or actually we'll say no switch port mode access, and we're going to say switch port mode trunk. And you can see there that the interface has changed to up. So if I say do show interface trunk, now we have a trunk port here, right? We've still got some spanning tree activity taking place, right? Because we can, as witnessed by the orange port. However, now the port is a trunk port. So let's see if I do a do show interface gigabit Ethernet 01 switch port. Now what is my administrative mode and my operational mode? Trunk, trunk. And that's exactly what we want, right? We want it to be a trunk port because that's going to allow multiple VLANs. And in our case, and let me grab my pen here real quick. So in our case, what we're looking at is we've got VLAN 10 for PC1, VLAN 20 for PC2, and VLAN 30 for PC3. They all kind of congregate right here. Let me get, where's my desk scribble at? There it is. All right. So these guys all get aggregated here at switch 2. So then switch 2 has to have the capability to send, and let me apologize here. I'm going to make this as small as I can. There we go. So now we'll pull the pin up. So switch 2, he's got VLANs 10, 20, and 30. And he needs to get those VLANs over to switch 1 and then down to the other side. Well, if this is specifically, if that is an access port, he's not going to be able to do that. So that access port, remember, an access port can only transport and be a member of a single VLAN. So what we're saying here is we've got to make that a trunk port because what we want is VLANs 10, 20, and 30 to go to switch 1 and then down to switch 3 because then they can shoot out to PC4, 5, and 6 and we can have communications there. So let me clear the screen here and I'm going to go ahead and say that on this side we're probably done. So I'll just say in and then I'm going to save my config. We'll say write mem. All right, let's check out switch 1 now. Let's see what switch 1's got going on here. So we'll make this a little larger to give us some more real estate. All right, so we'll pull the CLI up on switch 1 and let's go ahead and go in from user exec into privilege exec and then we're going to say show run. Take a look here and see what we've got. So we can see we're doing per VLAN spanning tree, which means we are not using rapid spanning tree. And then I'm looking at gig 01. And so what do you see here between these two ports? Now both of these ports are supposed to be trunk ports. However, what's the problem? If you're looking at gig 01 and saying to yourself, hey, wait a second, we just saw this problem over on switch 2, you're absolutely right, and that's the exact same problem. So here's what we want to do. We want to go into global config mode, if I can get that conf t in there, and then we're going to go in interface gigabit Ethernet 01, and we're going to say no switch port mode access, and I'm going to say switch port mode trunk. And it's going to bring that interface back up, and I'm going to go ahead and type in and write mem. So it's going to bring that interface up for us, and spanning tree is going to do its thing. If I were to say show interface trunk on switch 1, we should now see that gig 01, and right now it says that VLANs in the spanning tree forwarding state and not pruned. It says none, but let's wait for this port here, gig 01, to come back online because we should see that right there for gig 01 as well. All right, so now gig 01 is back online, and there we go. And this is really some of the most critical output down here, because you want to make sure that if you've got a trunk port and you're anticipating that that VLAN is going to be transiting that trunk port, you've got to make sure that it's in the forwarding state and is not being pruned. And so again, we've got our trunk port fixed now, so now we have 2 trunk ports on switch 1, which is really all we have, gig 01 and gig 02. So let's now come down and let's take a look at switch 3 as we're slowly making our way over to the other side of the topology. So what are some of the problems that we've seen? So we saw that PC3 had the wrong IP address. We saw on switch 2 that one port was in the wrong VLAN and that the gig 01 port was set up as an access port. So we had multiple issues there. Then on the switch 1 side, we had the gig01 interface was an access port, so we've resolved that. Now let's take a look and see what switch 3 is going to tell us about some of the issues that we're having. So I'm going to go from user exec into privilege exec, and let's just do a show run. So switch 3, we're going to be looking for the same things that we saw over on switch 1. So FA06, let's take a look at that first. For PC6, it says that FA06 is an access port, which is correct because we have a host on the other end. But then it says switch port access VLAN 20. Well, if I refer back to my addressing table, what do I see here? I see that my VLAN is actually VLAN 30. So let's go ahead and type Q here, and let's address this right now. I'm going to say interface FA06, and we're going to say switch port access VLAN 30. Now this definitely explains why PC3 could not reach PC6. Not only did we have a trunk link that was broke on switch 2, but PC6 wasn't even in the same VLAN. So even with the trunk links sorted out, we would have still not been able to ping PC6. So we're going to go ahead and allow that port to come up. And what I'm going to do here is from PC6, I'm going to try to ping across now, hopefully successfully, over to PC3. So 172.17.30.23. All right. So that has resolved the connectivity issue between PC3 and PC6. They're now on the same VLAN. They've got the trunk ports resolved, and there's connectivity. So that has been solved. Let's bring switch 3 back up, because something tells me that we're going to be looking at some more issues, maybe of a similar type. So now let's take a look at FA011, and that's PC4. Now PC4 is supposed to be an access port, and PC4's port is supposed to be an access port, and it's supposed to be a member of VLAN 10. We take a look here, and everything looks good on FA011. So let's go ahead and make our way down to FA018. Now FA018 goes to PC5. If we look at PC5, we can clearly see that PC5 is supposed to be a member of VLAN 20. However, when I look here, we're currently set up to be a member of VLAN 30. So let's go ahead and resolve that. So I'll say interface FA018, and we're going to say switch port access VLAN 20. And we might as well go ahead and make a run at it here. Let's check and see, can I ping across to my partner on VLAN 20, who is PC2, 172.17.20.22. So can PC5 ping over, and he's having some issues here. So request is timing out. And still timing out. So let's pull switch 3 back up and let's drive on. So we'll say do show run, and let's make sure. So there we go. And VLAN 6, I actually went by VLAN 6 right away by accident there. So VLAN 6, or I'm sorry, FA06, we resolved already. FA011, let me make sure I'm looking at this correctly here, that I didn't go buy something. So FA06 is PC6, and that should be VLAN 30, so we're good there. FA011 is PC4, VLAN 10, so we're good there. And then we come down to 18, FA018, switch port access VLAN 20, and that is PC5, and so that is correct. But let's cruise down here a little bit and see what might be wrong. So we've got gig02 is a trunk port, and the native VLAN is 99. All right, so switch 3 looks good. So let's go ahead and say write mem, and let me test. I believe, did we test? Let's try one more time. Let's make sure we can ping from PC4 here. PC4's VLAN 10, so it should be able to ping 172.17.10.21. All right, so PC4 has connectivity. PC5 is timing out. And let's take a look at PC6, who I believe we had connectivity from. All right, so we're clearly down to PC5 is having some challenges. Well, let's make sure, I'll do Control-C here. Let me do an IP config here. Let's make sure we didn't misread something earlier. So PC5 is FA018, and it shows that the IP address here is 172.17.20.25, and it is. Subnet mask is correct, and so let me double check. We've got the native VLAN defined there, and show run. The native VLAN is defined on both trunks, switch port mode trunk, so we're good there. Let's come over here to the partner and say show run, and let's take a look at FA018, which is going to be, should be VLAN 20, and did we miss something there? We did not. And now let's take a look at PC2. And let's make sure nothing changed here. 172.17.20.22, and that's correct. And the subnet mask is correct. All right, so we've got an issue that's out there right now, and explain the connectivity issues between PC1 and PC4. So we did that, and we saw that we needed to make the changes on the trunk ports as well as some of the access ports. Same thing with PC5 and PC6. And make sure we're not missing anything here. No, so everything is good. So let's check. Let me double check here. So VLAN 20. So gig 01 is properly show interface trunk. Let's make sure that VLAN 20 is in the forwarding state, and it is, and the port is not shut down. So from here, let's see if I can ping 172 dot, and actually we do not have, yeah, I don't have any SVI set up. My native statement, let's check back on switch 1. Show, whoops. We'll say show run. Ah, I think I just saw it possibly. No, not it. Whoops. Alright, so let's double check here on switch 1. And switch 1 really just has these two ports. Switch port trunk native VLAN 99. Switch port mode trunk, same thing. Trunk native VLAN 99. Mode trunk show VLAN brief. So all of the VLANs are defined there. Let's make sure the VLANs are all defined here. Show VLAN brief 10203099, and that's correct. And let's check switch 3. Show VLAN brief 10203099, and that's correct. All right, so I am 172.17.20.25, and that is correct. All right, so let's give it a go one more time to make sure that it's not 172, that I didn't typo something here. 17.20.22, because I'm trying to ping over to PC2. And it's interesting because PacketTracer is showing me that there's still something that's wrong that I'm not seeing. And I may be looking right by it here. So PC2, 172.17.20.22. It's port 18, VLAN 20. 172.17.20.22. And the subnet mask is correct. And FA018 is in VLAN 20, and it's active. And VLAN 20 is active here, and it's in the forwarding state. Alright, I'm scratching my head here. And VLAN 20 is active, FA018 here, and it's correct. Let's see if it's going to allow us to check results. Aha. It's not going to allow us to check results, so we're going to have to sort this out on our own here. Alright, this is an interesting one, because right now everything, as far as I can tell, looks good. Let's try to trace. Let's see what happens if I trace over to trace RT to 172.17.20.22. Do we get anywhere? And again, we're not going over a bunch of different layer 3 boundaries. This is all layer 2, right? So it's all layer 2 trunks. But I was just curious to see if it's going to show me something different. Ports configured for the correct mode. Ports connected to the correct devices. Document the problems. So it's got to be something simple that I'm looking right by here. FA018 on switch 3. Let me do this. Let's do a write mem. I'm going to make sure we're not experiencing the classic PacketTracer any PacketTracer issues here. So we're going to let this switch reboot, and then spanning tree is going to convert. Whoops, did not want that. So spanning tree. Spanning tree is going to finish converging up there, and so we're going to say show interface trunk and gig 02, and there we go. As soon as it converges, we'll have our VLANs in the forwarding state. So we've got that. The native VLAN is correct. .1Q show VLAN brief, and we've got 10, 20, 30, 99. So those are all correct. And they're active. Let's see if I can get over there. Whoops. So we do Control C, and we'll see if I can get over there now. And I cannot. 172.17.20, and that is correct. Huh. So this is definitely a good. Oh, whoops. This is definitely a good one here. Let's just double check. 172.17.20. 20, 25. And this should be forwarding Pc2 172.17.20.22. Huh. Brief. Do a show run. Let's double check one more time. Maybe I'm looking right by it here. Port 18, switch port mode access, switch port access VLAN 20. That is correct. So I'm not sure what it is that is still incorrect. Documentation in part 2. Step 3 is worth 30 points. So listen, necessary actions. So I'm going to pause here for a second and think about this to see if maybe there's something I'm overlooking. But I will be right back. All right, so I'm back, and actually just a couple seconds ago I had to run out and then come back, but just sat down here and was walking through a couple of things, basically looking at all the ports. And here's what's interesting. So when I do a show run, right, you'll notice that it says that FA018 is a switch port access VLAN 20, switch port mode access. So on the left-hand side, what I did on switch 2 was I ran through a series of the switch port commands, right? Show interface switch port to make sure that they're static access ports and that they're members of the right VLAN. I came over to switch 3 to do the same thing. And where are we at? Show IP interface brief. So I did show interface FA018, 011, 06. So when you do 06, you'll see it says static access VLAN 30. That's correct. Let's now take a look at FA011. And you'll notice it's static access VLAN 10. That's correct. But when we take a look at 18, and this is interesting, you'll notice it says static access operational mode down, right? Now, if it's down, you'll notice that we've got green link lights here. So the link lights show green. They show up and up. When I do a show run, right, what do we see? We see that the port does not say shut down. So it should be up, because if the port is shut down, it would say shut down under the port. So it wasn't until I ran the switch port command for FA018 that I was able to see that it thinks that the port is down. And so here's something else that's interesting that I noticed. And I don't know if you guys picked up on this or not. Do you notice where it says switch port here? And it says, you know, make sure that on the switch that the ports are correct. Well, why does it list switch 1 here? However, switch 1 is there, right? Switch 2 is the one that should have the ports to it, as well as switch 3, unless this was supposed to be switch 1, this was supposed to be 2, and this was supposed to be 3. So it's one of two things. Either that was supposed to be 2 and this was supposed to be 3, or this was supposed to be 3 and that was supposed to be left as 2, or they mixed it up over here. In any event, let me go ahead and clear the screen here. So yeah, so this is an interesting one, right? So it says that the port is shut down. Okay, well, how do we bring up a port? We go into global config. I say interface FA0/18, and I'm going to say shut, and it says administratively down, but you'll notice the link lights did not go down. And then I'm going to say no shut to try to bring it up. And you see what it says? Interface fast Ethernet 0/18 change state to down. So for whatever reason, it thinks that this link is down. And again, it shows that the light is green here. If let's plug this back into FA018. So I basically just clicked it and moved it and plugged it back in, and look what happened. We end up with the 10 points. So I'm still not clear. Maybe was there something here that said it was half duplex? Because it doesn't even show that in the config, right? The config just shows it should be up, right? Where we ran the switch port command, I'm hoping that it's still here. So it shows down, and it doesn't show the duplex. I didn't do the show int command. But again, me simply unplugging it and then plugging it back in, which doesn't really do much of anything. We would have gotten like duplex mismatch errors if it was a duplex problem. So I think this is just one of, again, we've got issues here in the addressing table with the switch port, with the switches that they list, not matching with what they have over here. So it's very possible that this is just simply an oversight, maybe a bug that might be fixed in the PacketTracer 6.2, which is the new release. I'm running 6.11.0001. So let me go ahead and type in here, and then let's go ahead and run that final test, which is, can we ping over to our partner? And now we can. So again, on this one, it really came down to running the show interface switch port command for FA018 on switch 3, right? And it's clearly switch 3. That's what it's labeled as switch 3. And seeing that even though the port did not say shut, it wasn't administratively down, it just showed that it was down. We did a shut, no shut, still did not bring it up. And all I did was literally click on it, unplug it, and plug it right back into the same port. And it worked. So maybe I looked past something, and I'm not sure if, again, if maybe it was just some sort of a PacketTracer bug. But that is it. So this completes PacketTracer tutorial 3.2.4.7, and hopefully this cleared up any confusion that you might have had. And I can definitely see where, as a new learner, this may have caused some serious problems in terms of trying to troubleshoot the problems. All of them except for that last one right there, and I'd be curious to know if others receive that the same results. They end up with 60 out of 70, and this port, even though it's showing green, shows it's down, and you've got to unplug it and plug it back in to get it back up. All right, I really appreciate your time for watching. Thank you so much, and I will see you guys on Saturday.